All right, so first thing I wanted to say is thank you to the conference organizers for putting the event together and for inviting me to come speak here. Second, I wanted to thank all of you for actually coming to my talk because otherwise it would be pretty lonely in here. So my name's Colin. I've been working on Node.js I've worked with Node.js since like 2012 or something like that, and on the Node.js project itself since 2014. Today I'm going to talk about the state of Node.js core. Let's dive right in. So the very first thing I wanted to say is Node is still popular. People are still using it. I have a graph here showing the downloads from nodejs.org. The start of the graph is roughly the end of March 2021, all the way up until I pulled this data yesterday. So you can see, the graph is still going up and to the right. We've gone from about 2 million downloads up to 4.5 million. So you can see the raw data for this if you go to nodejs.org/metrics. You're just going to get numbers. You have to compile the graphs yourself. Next, I wanted to talk about the NPM ecosystem. So it's also still popular and growing. This is not directly related to Node Core, but it's kind of a proxy for what's going on with Node. So the red arrow kind of points to where NPM package count is today. You can see it's a pretty wide margin above every other ecosystem. But I don't want to pump up NPM too much because there's a lot of bad packages on there. There's a lot of malware and things like that. But like I said, the ecosystem is still growing. So this is probably the most important slide that I'm going to show today. So if you're using Node in production at your company, it's really important that you understand what's going on here. Before I explain what's going on in the graph, I want to do a very quick history lesson. Back in about 2009, Ryan Dahl created Node.js. Shortly after that, he was hired to come work at a company called Joyent. They acquired the project and they became the corporate stewards of Node.js, with Ryan acting as the BDFL, benevolent dictator for life for the project. This basically means he was in charge of everything. He made all the decisions. At some point along the way, Ryan decided he was going to move on to other things, and a new BDFL named Isaac Schluter came along. Isaac was the BDFL for a little while, and then he moved on to a small project of his own called NPM, which you might have heard of. After that came a guy named TJ Fontaine, and that takes us up until about the 2014 timeframe. So around this time, the community started to get unhappy with the speed of development of the project, and specifically with Joyent's management of the project. So if you've been using Node for a long time, you may remember that there was a fork of Node called IO.js. So IO.js looked to empower the community. So instead of having a BDFL, it went to more of a consensus-driven model driven by open governance. And one thing it did was it moved way too fast. So around that time, I was working at Walmart. I was contributing to Node and IO.js. And I can say at Walmart, we had never even considered using IO.js because it was just, for an enterprise use case, it was just moving too quickly. There was too many breaking changes from things that were coming in every day and things like that. So eventually, the Node project and the IO.js project came back together. We had convergence back in, I think it was roughly 2015. And so around that time, we kind of realized that we needed to somehow balance what the two projects were doing. We needed to move fast and add new features for the community, as well as balance the needs of the enterprise, which values stability and not breaking things. And so around 2015, we came up with the long-term support schedule. There have been very minor tweaks to it since then, but it's largely stayed the same since then, which is nice. All right, so now back to the graph itself. So Node.js maintain several release lines concurrently. The top line in yellow is Node's main branch. This is where all of the development happens. This is where every change lands, patches, new features, breaking changes, all of it. All of the other release lines are then separate Git branches. So we have a team of releasers who look at the commits that have landed on the main branch and cherry pick them over to the appropriate branches to actually be released out to users. The way it works is twice a year in April and October, we have a Semver major release. So a new major, that's where the breaking changes can reach the users. And every April, we release an even-numbered release. So this past April, we released Node 20. Every October, we release an odd-numbered release. So this coming up October, it'll be Node 21. And the way it works is odd-numbered releases, all releases become what's known as the current branch, and that's shown here in green. And that goes on for a period of about 6 months. They receive all of the changes that are non-breaking. And then after that 6 months, the odd-numbered releases go into a very short, what we call maintenance period, for, I don't know, a month or two before they are then end-of-lifed, and we kind of forget about them. The even-numbered releases are much more interesting, though. So after they have their time as the current release, then they become what's known as active LTS, which is shown here in blue. So at this point, we kind of lock down the commits that get cherry picked back to these release lines. So there's no breaking changes, hopefully, and we are a lot more cautious about what gets backported. So things have to be released in a current release for 1 or 2 releases to make sure that there's no glaring bugs before we backport things. Then after a year of LTS, things go into maintenance, which is basically they receive fewer and fewer updates, important security updates and things like that, and then finally they become end of life. So the chart right now, the red line going down the middle is where we are in time. So I'm showing it as July 2023. That's in a couple of days. You can see that Node 14 is end of life, Node 16 is in maintenance, Node 18 is in active LTS, Node 19 is end of life, Node 20 is our current branch. So now I want to talk about each of the release lines in a little bit more detail. So one thing I didn't mention is all of the LTS releases get a code name that's based on the periodic table of elements. So starting with Node 4, I think it was the first one we went with argon, Node 6 was boron, Node 8 was carbon, et cetera, et cetera. Some letters don't have a periodic table element. In that case, we just kind of make one up. I wish I was lying, but I'm not. So Node 14 was known as Fermium. Its end of life was just April 30th of this year. There will be no more releases, including for security fixes. So if you're running Node 14 now, you're running an insecure version of Node. You really should update as soon as you possibly can. I recommend migrating to Node 18. So next is Node 16. Node 16 is still alive and well. It's still being supported. It's got the Gallium code name. So it should have been supported until April of 2024. However, we had to bump that up by a few months because the version of OpenSSL that we ship with Node 16 is also going to be end of life. So the options were kind of, ship an unsupported version of OpenSSL, which is bad. Try to maintain it ourselves, which is also bad, or just kind of, cut Node 16 a little bit short. So that's what we decided to do. So this coming up September 11th, OpenSSL and Node 16 will both be end of life. So if you're still using Node 16, I recommend that, if you haven't migrated off yet, you should at least start looking into that. Node 18 is a pretty easy jump from Node 16, so you shouldn't have too many headaches along the way. And then I've also included the official blog post announcement at the bottom of the slide here. So if you want to go and read in even more detail than what I'm telling you, feel free. So next is Node 18. So this is the hydrogen release. It's currently in active LTS. This is, it's nice and stable. It's been kind of battle tested for a while now. It's going into maintenance in October of this year, but it'll still be supported all the way through April of 2025. So this is what I recommend you use if you're running Node in production now. Next is Node 19. So this is the first odd-numbered release I'm talking about. Like I said before, odd-numbered releases never quite make it into LTS. You should ideally never be running an odd-numbered release in production. People still want to do it. Sometimes it works out for them, sometimes it doesn't. The only thing that's kind of really notable about this release was we removed dtrace, system tap, and ETW. So these were kind of debugging and diagnostic probes. The real underlying issue was nobody was maintaining them, so they kind of bit rotted a little bit and weren't quite working right. There's an open issue on the issue tracker. If anyone is really feeling like they want to bring them back, I encourage you to jump in and try to do that. So then moving on to Node 20. So this is the most recent release. It was released in April. It's going to go into LTS later this year, and it's going to be supported all the way up until April 2026. So it still has a lot of life ahead of it. There are actually a ton of new features that have come in this release, and I'll get back to those in a little bit, but I want to kind of go on a little side quest first. So here is the breakdown of usage by version. So this is taken from the same data that I took the total downloads from and broke it out by releases. If you add these all up, they don't necessarily add up to the total numbers because that number includes ancient releases. So, 0 dot whatever, Node 1, Node 2, 4, all the old end-of-life releases. But what's kind of interesting to see here is that the Node 14, which is this blue line, is kind of on the decline. It had a little spike here. I'm not really sure why. I think that might have been its last release and people kind of started to download it. But importantly, it's falling off. Node 16, which is the orange line, you can see it was growing and growing, and now it's starting to decline. Node 18, which is this yellow line, is really growing quickly. That's what we want to see. Node 19 is the green line. It had its short life and then died off, and then Node 20 came into existence at the end here, and then just kind of, it's hopefully will continue to keep growing. Fun fact, this dip and this dip in downloads actually correspond to Christmas. So if you're wondering why nobody was downloading Node around that time, that's why everyone was on holiday. So now I want to talk about what version you should be running in production. Everybody always wants to have the latest and greatest features. It's kind of a toxic trait of developers. They always need to have the latest and greatest. But you really need to ask yourself, if your company is really relying on Node in production, is it mission critical? If it's not, maybe you can afford some of the breaking changes that sometimes sneak into the current release line. If it is mission critical, definitely want to stick to LTS. Another aspect is, can you change between versions easily and frequently? So the current release line sees many more releases than the LTS lines, which get released, I think, roughly once a quarter or so. So if you're using the current release line, you need to be able to be a little bit more agile with the version that you're supporting. And then, like I said, do you need the latest and greatest features? Everyone will always say yes, but I just want to give you a little word of caution. So this is something that I tweeted out a couple weeks ago related to Node 20. Node 20 is great. It has a lot of great features, but it has not been smooth sailing. So there have been, happy eyeballs, which I'll talk about in a little bit, has been a nonstop stream of breaking changes for people. ESM loaders, which is how you can kind of configure the way ESM modules are loaded. There was a very significant breaking change in Node 20 where they were originally loaded on the same thread that your application was running on. Now it's loaded on a separate thread just for loaders. And this introduced all types of edge cases and things like that. If you've ever used Node worker threads, you know that there are a substantial number of edge cases. They work really well for what they're supposed to do, but you can't access certain APIs, you can't do certain things. So all of those things kind of fell into the laps of people who are using loaders. And then kind of the excuse there has always been that they're still experimental and people shouldn't be relying on them, but it's also the only way to kind of control ESM modules at this point. And then IOU ring, which I'll also talk about, is this great thing that came into libuv, which is the C library that gives Node.js its event loop. But it has interacted poorly with Docker. So there have been some setcomp filter things in Docker where it didn't really quite know how to handle the new IOU ring code. And so it hasn't been working for people. So, if you're thinking about using Node 20, again, try it out, but just be careful, and if things break on you, I warned you. All right, so with that, let's talk about all the fun stuff. So new features from V8. One thing is shadow realms. If you've ever used Node's VM module, it's kind of the language specification equivalent of that. So it basically gives you a context that you can kind of spin up a new, not Node environment, but a new JavaScript environment in. There's also find and find last index for arrays. That's, if you've used find or find index, it's the same thing, but from the back of the array. Really interesting thing that got added to the spec recently is change array by copy. So I have two sorted here, but there's actually a couple other methods, but they don't fit nicely on the slide. So if you've ever used array.prototype.sort, you might have found out the hard way that it sorts the array in place. So the array that you provided is then mutated. So it's kind of surprising when the thing you pass in gets changed. ToSorted does what sort does, but it gives you back a new array. The original array is left unchanged. There's been some performance improvements for class fields and methods. So when private class fields were first introduced in V8, and it's actually kind of common for a lot of new features in V8, they're not quite as optimized as existing features. And so even inside of Node Core, we didn't use them until V8 kind of optimized them properly. So they've caught up now, and you should feel free to use all of that nice stuff. And then the last 2 points here are related to WebAssembly specifically. So the JavaScript promise integration is a really nice thing to have for WebAssembly, because if you've ever used WASM, it's more or less completely synchronous, but it can call out to JavaScript code, and a lot of JavaScript code is asynchronous. So there wasn't really a good way to call asynchronous JavaScript code, get the result back, and then do something with it. So this integration will make it much easier for async JavaScript code and WebAssembly to play nice together. WebAssembly also got tail calls recently. So this is just a compiler optimization that can change certain types of recursive functions into essentially a for loop. So it's good for WebAssembly performance. Next, I wanted to talk about some of the new features that we've gotten from the web platform. So these are things that don't necessarily come from V8 and the JavaScript spec, but are part of the web platform. So a big one is fetch. People wanted fetch for years in Node Core. We finally made fetch happen. Yay. So it comes with some other things like request and response objects, form data, and things like that. Another big one has been web streams. So if you've ever used Node streams, web streams are kind of the web platform's answer to that. An interesting fact about web streams inside of Node is they are currently slow enough that you can debug them with the naked eye. So they're really good for compatibility, but the performance is not quite there yet. There's also web crypto, which is the web platform's answer to Node's crypto module. Structured clone, it's a great API for making copies of objects and things like that. Text encoder and text decoder are the web's answers to Node's string decoder module. Blobs and files are just different ways of kind of representing data. Event target is the web platform's answer to Node's event emitter module. And then a really interesting one that's been coming up recently is symbol.dispose. There's also symbol.async.dispose, but again, limits on how much room is on the slide. Basically, this is part of a new TC39 specification for the language that will let you explicitly manage resources. So say you have a stream and the stream is no longer in scope. When it's garbage collected, you can set this symbol as a function on the stream, and it will automatically take care of closing down and cleaning up the stream for you. So you no longer have to explicitly call these functions yourselves. And then there's some more, but time limits. The next thing I wanted to talk about is the test runner. This one excites me because I worked on this a good bit. So there's a new core module called Node.test. It has APIs for creating tests. And then there's a new CLI flag, --test, which is the actual test runner itself. So it'll take one or more files, run them, and then give you back results. You don't have to use the two together. I could do an entire talk on the test runner, but I think there's actually one later today that you should go check out. There's also a test module on NPM, so this is less relevant now. When Node 14 was still supported, the test runner was not backported to Node 14, so some people were kind enough to take the code, pull it out into a separate NPM module. Somebody actually owned the test module on NPM. They were kind enough to hand it over because they weren't using it anymore. So that was one way that you could get it on older versions of Node. The test runner supports a lot of the things you would expect for a simple test runner. Subtest, you can skip tests, have only tests, so things that, if you specify it, it's the only test that'll run. Lifecycle hooks, so before each, after each, all of those things. We also have mocking, so we have function mocking, so you can do things like spies and stubs and whatnot. We just recently, I don't think it's actually even been released yet, implemented timer mocking, and soon we will have module mocking. I have a branch basically ready to go. It's just waiting on some other APIs inside of Node to stabilize a bit more. We support code coverage with the experimental test coverage flag. It takes coverage data directly from V8 and formats it into a little report for you. We have different reporters, so we have reporters that are more human-friendly and human-readable, other ones that export the data in something called the Test Anything Protocol, or TAP. That's more machine-readable. It works across different languages, so you can chain tools together and whatnot. And so if you're sitting at your terminal and you're on a TTY and you're running your test suite, it'll give you the nice human readable one. If you run your tests in the CI, it'll give you, the TAP output, which is more machine readable. So what do the tests look like? We have an example of a synchronous test and an asynchronous test here. The synchronous test passes. I'm using Node's built-in assert module here. You don't have to use it. You can use any assert module out there that throws exceptions on failures. The asynchronous test fails because 1 is not equal to 2. So we support asynchronous that returns a promise, or we can even pass in callbacks because Node still has a lot of legacy callback-based APIs. And then what does the output look like? So on the left, like I said, kind of ugly machine-readable TAP. On the right, nicer, colored, human-readable, it's called the spec reporter. You can define your own reporters. There have been ones created that will kind of integrate with GitHub and things like that. So I encourage you to play around with that. So the next thing I wanted to talk about is these, basically, it's called a Node-only core modules. Every core module in Node can be run with or without this Node : specifier in front of it, except for the test module. When I was building the test runner, I originally called it test runner. People wanted to call it test, but it didn't really, because there was, like I said, there was an NPM package already. It wasn't going to work out. So the TSC decided that starting with the test runner, and likely with all new modules moving forward, we would actually require the Node prefix. So before the test runner, you could choose to use or not use it. And so the example here, at the top, you'll get Node's test runner and you'll get Node's assertion library. At the bottom, you'll get an error, or I'm sorry, you'll get an error because test has to be with node test. Otherwise, it's going to try to load from your node modules directory, whereas the assert module will still be node core's assertion library. We've also got watch mode recently. So there's a -- watch command line flag. What it'll do is all the modules that your app reads in, it'll actually watch those. So if you change any of them, it'll reload and restart the application for you. If you've used tools like NodeMon, it's very similar to that. You can customize what gets watched on Mac and Windows with the -- watch path. So I encourage you to give the watch mode a try. We also got util.parseArgs. This was introduced in, I think, Node 18. It's now stable in Node 20. If you've ever done any type of command line tools in Node, you've probably used yargs or commander or minimist or one of those libraries. This is now kind of a built-in core alternative to those. So you can specify, the data type for your flag, and when you pass things in, it'll handle automatically converting to the right data type and all of that stuff for you. Another new feature that a lot of people seem excited about is single executable applications. So if you've ever tried to, built an application and tried to distribute it to people, you always have to tell them, okay, install Node, install npm, run npm install, et cetera, et cetera. The way this works is you can actually just take the node binary, take your application code, inject it directly into the node binary, and then give people the node binary to run directly. It's still a little bit limited. It's a new feature. You can currently only do this with a single common JS file, although we're working to improve that. So what you would do is you would bundle your application down into a common JS and then inject that into your application. The Node project has a little utility called postject. The naming comes from the fact that it came from Postman Labs, who was kind enough to donate the project to Node Core. There are similar tools out there to postject. We don't test them in our CI, so they should work, but again, untested. We also got a permission system. So this is a way to kind of lock down what Node.js has access to. It's still experimental, and we just had a security release, I think it was last week, version 20.3.1. And if you look through that security release, you'll see a bunch of CVEs related to the permission system. Because if you introduce a feature specifically related to security and it doesn't work perfectly the first time, you have security issues. So I would recommend playing with it. Don't rely on it, certainly not in production. It's not going to replace running things inside of Docker or Firecracker or however you isolate your Node.js process. But it does have potential. And so there are a number of CLI flags. So first you would pass experimental permission to turn on the permission system. That'll basically lock down access to the file system, lock down access to child processes and workers and things like that. And then from there, you can kind of start reallowing things. So you can, for example, if you wanted to allow file system reads, you would use -- allow fs read. That would give you access to read anywhere on the file system. You can configure it a little more granular than that. You could, say, allow read from a specific directory or directories and things like that. If you've ever used Dino, it's a similar feature to Dino's permission system. So some other notable changes, I mentioned IOU ring before. So IOU ring, first off, it's Linux specific. So if you're using Mac or Windows, you're not going to see any benefit here. But it's something inside of the Linux kernel that allows you to do IO more efficiently. So right now, it's only for certain file system APIs. There's ongoing work to port it to like network APIs and things like that. But we, with benchmarks, we've seen, I think the best benchmark showed like an 800% improvement in performance. So if you're running on a Linux machine in production, once IOU ring is there and is nice and stable, you should see significant performance improvements. We've also had some added streams helpers. So you can take a node stream, you can convert back and forth between node streams and web streams. You can do things like map and for each on chunks of streams and whatnot. So just nice little utility functions to have. fs.statfs is a new API that allows you to access the disk and kind of see how much storage you have available, things like that. Happy eyeballs is a DNS lookup thing where it'll try IPv4 and IPv6 at the same time. So it's good if you have kind of an interesting networking setup. A new URL parser, which is supposed to be really fast, experimental HTTPS imports, a whole bunch more. We also have some potential upcoming features. So I should, just say that there's no guarantee that all of these will happen. Until they actually land, they can always, not land. But FFI, so if you've ever used Node API for doing compiled add-ons, FFI is kind of an alternative to that. When we were originally designing Node API, FFI was kind of an alternative take that we thought about implementing. Somebody decided to pick it up and run with it, so I think that there's a good chance that'll land. We're hoping to get better TypeScript integration out of the box. We're not going to bundle the TypeScript runtime inside of Node. It changes too frequently. It has breaking changes. It just is not compatible with a long-term support schedule. But we're looking for different ways to try to improve that. Quick, which is essentially HTTP 3, is the promise of bringing faster networking. So that's been a long process. The person who's been primarily working on it has had less time to work on Node Core. So it's been moving a little slow, but it is still progressing. As I said, we're hoping to get more APIs backed by IOU rings so that all the Linux servers in production will just magically get a lot faster. We're hoping to promisify more of the core modules. So Like the FS module and the DNS module have promise-based implementations instead of callbacks. We're hoping to add more of those. And stable ESM loaders, especially with the Node 20 release, they caused a lot of pain. So we're hoping to really get those stabilized in the near future. And then I wanted to talk about some important links. So if you have a bug report or a feature request, go to Node.js/node. If you have a support question, Node.js/help. Curious about the release schedule I showed, Node.js/release. If you found a security issue, do not report it publicly. Go to hackerone.com/Node.js. And then we have a Slack channel. So there's a Node.js channel for general Node questions and a Node.js core specifically for Node.js core. And that's all I've got. I'm working for a company called Platformatic. If you're doing any type of backend development, it can really accelerate, start creating your Node.js, GraphQL, REST APIs, things like that out of the box. Thank you.